Okay, so this is a chapter on economic data, and we're going to use economic data from the United States, and we're going to get it from what's called the Federal Reserve Bank of St. Louis. And we're going to consider 4 economic measures: the unemployment rate, the manufacturer's new orders, durable goods in millions of dollars. That means how many new orders are being produced in the country, and that's an important measure of how the economy is doing. The consumer sentiment index. So that's a measure of how consumers are feeling. Are they feeling positive or negative? So if consumers are feeling positive about the economy, then they're going to shop more, and that's going to improve the economy even more. And this says the first quarter of 1996 is considered to be 100, because how do you measure consumer sentiment? It's not measured in dollars. So we need to assign a certain time, for example 1966 first quarter, and we'll call that 100, and then it'll go up or down from 100. And finally, new homes sold in millions. So how many new homes are being sold this year? That's also an economic measure. And these 4 economic measures are called leading indicators, meaning that they occur before the economy changes. So if these increase, for example, not unemployment, but if employment increases and new orders increase and consumer sentiment improves and so on, that means that we expect that in the future the economy is going to improve. So these are called leading, meaning that they occur before. So one thing in R that we'd like to do is graph the 4 of these and graph them all together in one panel. So we want to learn how to do that. And you can see that they all drop around here, which is what we call the Great Recession of 2009, I think it was. So we can see that they all drop then. And we're going to collect these into what we call a single time series object. So we have things like factors and lists and so on. Another object that we can make is what we call a time series object, and we're going to put them all into one time series object. In our R code, we'll see how we do that later. So we're going to label these as IER, meaning the employment rate. I stands for index. We're going to index it. This is, what was this one? Durable goods, consumer sentiment, and new homes sold, all with an index, all as indexed. So he says parallel indexing can be especially useful in the analysis of multiple time series. So it means, so the University of Michigan, the consumer sentiment was, we called that 100 in 1966. He says that it turns out that it came back to 100. It might have gone up and down, but came back to 100 in March 1997. And during that time, at March 1997, we have observations for all the other 3 series. So we're going to use 1997 March as our reference date for, and we're going to set all of the other indices as well to 100. We're going to scale them to be 100 on March 1997, and that will be useful when we make what's called a horizon plot. So this is an example of what they mean by horizon plot. These are slightly different quantities. This does have employment rate. It has consumer confidence here and some other things that they didn't mention. But the idea is that they're all scaled to 100. So this one and this one, these are all separate time series. They're all scaled to 100. And then, so instead, what you can do is you can put these all together like this in a single panel here, and you can actually put even a lot more than just however many I have, 1, 2, 3, 4, 5, or 6, or whatever I have here. You can put a lot more there, and you can kind of compare them together. So for example, what I mean by compare them together is, well, first of all, how do you read this? So if it's blue, that means it's above the baseline, and the baseline we set to be all of them to be 100. We want them all to have the same baseline, so that's why we did that. So we have them all equal to 100. So this means that this is say employment rate here. Employment rate is, if it's blue, it means it's above the baseline, so above 100. If it's red, even though it's pointing up, it means it's actually below the baseline, so it's less than 100. And dark blue means it's from here to here, it's not dark blue, it's lighter blue, so it's high, but it's not as high as when it gets into this range. It's in the dark blue range. So that means really it looks like, let's suppose I did this one. So here it looks like this, and then up here it goes even higher. So that's what this means. So that's what the darker as opposed to the lighter blue, and the darker red means it drops down further than the lighter red. So just to give you an example of how you might use this, so we might look for relationships between these variables, and here it looks like there's a relationship between this, and it's not a perfect relationship, but when this is red, maybe this is also red, and when this peaks, maybe this also peaks. Not exactly, but there's some kind of relationship there. So it allows you to look for relationships between these variables. So he says here, with each economic measure scaled so that its value on March 1997 is 100, we can plot the multiple time series using a horizon plot. So we're going to do that. You're going to do that. And you should realize that horizon plots are very, very new. Not many people know what they are, know how to read them. It's a new visualization technique, and so you might have to explain to other people how it's read. And his footnote on this horizon plot is, it was introduced by Heer, Kong, and Argawala in 2009. The horizon plot represents a space-efficient data visualization for multiple types here. So space-efficient just means you can put a lot of them in one panel. To make a visual like the one shown, so to make this kind of horizon plot, we first determine a center value or origin, a reference point for the standardization across the time series. Our choice here was to use the index value of 100 as the origin. Then, instead of plotting each individual time series with its actual values, we plot both below origin and above origin values above the bottom line of each panel, right? That's what we did. We had the red and the blue above the line, with below origin values in one color and above origin values in another color. The intensities of the color reflect the degree to which the time series are below or above the origin. Okay, let's stop here and we'll continue with a new video.